Good afternoon, everyone. I'm in the floor this evening to show you what we got to do this week. This week we used base 10 blocks to solve 3 by 1 digit multiplication problems. Still working towards area models. Let's get right to it. Our problem that we mainly worked on was this problem. There are 5 beehives in a garden. Each beehive contains 137 bees. How many bees are there in total? So this problem ultimately is wanting us to multiply 5 times 137. So literally what that means is we just need 137 5 times. So we start with the base 10 blocks and we make 137. There's 1 100, 3 tens, and 3, 6, 7, 1, so we have 137. But we want 5 times 137. So we're going to duplicate this 4 more times. I don't know if I have enough room to show this on the screen. I tried. Notice it's very important that I'm keeping these in their groups. Well, I guess I could stack them like that. Okay. This is how most of the students started representing it anyway. So here's 137. Here's 130. We need our 7. 7. 2 groups of 137. 3 groups of 137. 4 groups of 137, and 5 groups of 137. So this is the quickest and easiest way to represent 5 times 137. But we want to know how much it is total, so we want to find an efficient way to solve that. Well, we could add all this together. We could put all the hundreds together, all the tens together, all the ones together, and then we could regroup. I'm going to just start by putting all the hundreds together. I'm going to keep the same amount of blocks, but I'm going to organize them according to place value. So I'm going to put all my hundreds together. I'm going to take my tens, put them together. And my ones and put them together. Okay? And of course, you can't see that. There's my hundreds, my tens, my ones. Okay. This is great. We still have 5 groups of 100. Well, we really don't have 5 groups of 137, but we have the same amount that we would have had with the 5 groups of 137. So our goal with the area model and the arrays is for us to show both the total number that 5 times 137 makes, as well as the original equation, 5 times 137. So we still want 5 times 137, but we want to count it efficiently. So the way we solve that is we organize them according to place value, but even more, we want to keep them in their original group. So I'm going to have my 5 groups of 100. I wouldn't normally stack them. I'm not going to stack them. I wish I could zoom out. Let's see if this helps out. Not really. Okay, there's 5 groups of 100. I just have a bunch of 10s here. I don't see groups of 30 anymore, but I can make my groups of 30. So I have 30 here, 30 here, 30 here, 30 here, and 30 here. And so now, rather than me just counting 1, 2, 3, 4, 5, 6, 7, I can group these as 30. So this is 100, 200, 300, 400, 500. This is 30, 60, 90, 120, 150. And then if I get these back in my groups of 7, 4, 7, 14, 21, 28, 35. So we can still see that we have 100, we have 30, we have 7, but we have 5 groups of it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We did this just on the floor, and then we took that and we put it on poster board. I'm gonna shift spots here and continue this conversation. This is pretty much what the students ended up working, what they ended up making as final products. Now they did do more decorations on theirs, it's more colorful than mine, but we wanted to, this is a whole different problem than I did just a moment ago, of course, but we have grouped all of our hundreds together. We've grouped all our tens, we've grouped all our ones. So the students, they had their 5 groups of 100 in one box, and it showed that we have a section for the hundreds. The way that they would have labeled it was 5 here. We have 5 groups of each of the hundreds, of the 30s from our original problem, and our 7s from the original problem. Up at the top, we labeled the amount that's in each group. So in mine, it was 200. In the students, it was 100. And then it was 30 here and 7 here. So they literally had 5 groups of 100, 5 groups of 30, 5 groups of 7. Down at the bottom, they get we write an equation to represent that. Now this right here, the equations, this is what we're moving towards. We want to get rid of the base 10 blocks and not have to draw this every single time. But as I talked about last week, there's the concrete, representational, abstract teaching method, I guess you could call it. The concrete is the base 10 blocks. This is the representational. We're drawing the base 10 blocks. This is the abstract. We want to get rid of the base 10 blocks and just move to this. So it'll be this outer structure. We'll have the 3 spaces, the hundreds place, the tens, and the ones. And we're just going to be writing these equations in the future. But for this week, this is what we did. So they would have had, for their problem, 5 times 100 equals 500. 5 times 30 equals 150. And 5 times 7 is 35. When you add the total areas of each of these sections, you get your total for the original problem, which in their case, it was 5 times 137. And it gave them 685. Ask your students about it, see if they understood it. If you would like to, you could give them some 3 by 1 digit multiplication problems and ask them to draw an area model with 3 sections. The 100 section needs to be largest, the 10 section needs to be a little smaller, and the ones would be even smaller if we are accurately representing them according to how much is actually in each space. Next week, we'll continue this, but we're going to move into the more abstract. We're getting away from the base 10 blocks again, like I said, and we're moving towards this. Thursday and Friday will be carving pumpkins. So if you have not sent in a pumpkin for us to carve, please send that in before Thursday so we can have as many as possible for our counting collections. That's it for this week. Have a good afternoon and a good rest of your weekend.